Hello, this is Mrs. Brown, and we're going to look at area and perimeter on the coordinate plane today. So looking at this, the first thing you want to do is look for horizontal and vertical lines because that makes life easier. So for instance, this line and this line are both horizontal. Let's say I'm going to start with perimeter. Perimeter is the distance around the outside. So I need this length, this length, this length, and this length so I can add them together. So if I start, this is 1, 2, 3, 4, 5. And this horizontal is 1, 2, 3, 4, 5. Now for the diagonals, I can't actually use, I can't count the boxes. I'm going to have to use something like the distance formula in order to be able to do that. One of the things that you might notice is that this and this are the same length. And if I look and I do, this is down 3 and over 1, and this is down 3 and over 1. So they have the same slope. This is actually going to be a parallelogram, which means that this and this are going to be equal. So I only have to use the distance formula once. So I could do the distance formula using these 2 points, or I could use these 2 points, and then both of them will be the same. If I get to pick, I'm probably going to pick the positive ones. So if I'm picking point B is 2, 4, and point C is 3, 1. So I'm just going to use the distance formula. Remember, the distance formula means that we have x2 minus x sub 1 squared plus y1 or y2 minus y1 squared, all under the square root sign. Okay, so in other words, I'm finding the difference of the x's and squaring it, find the difference of the y's and squaring it, adding them together and taking the square root. All right, so if I do 3 minus 2 squared plus 1 minus 4 squared. That's going to be 1 squared plus 3 squared, negative 3 squared. And so that's just going to be 1 plus 9 and the square root of 1 plus 9. So it's the square root of 10. And the square root of 10 is approximately 3.16. It's not going to be a whole number because 10 is not a perfect square. So this is about 3.16, and this is about 3.16. So to find the perimeter, I'm going to just add all of my sides up. Okay, so that's 10, 16.32 units. And that would be my perimeter. So again, any horizontal or vertical lines, I can count the boxes. The diagonals, I'm going to use something like the distance formula in order to find that missing piece. Okay, if we go for area, okay, area of a parallelogram is base times height. Base times height have to form a right angle. I know the base is 5, the height is 1, 2, 3. So my area is pretty straightforward. It's just 3 times 5. So that would be 15 units squared. Okay, so when you're looking at a regular shape like a triangle, a parallelogram, usually part of it is either vertical or horizontal, which makes it a little bit easier. But sometimes we have weird shapes. So let's take a look at another example. Okay. So let's take this shape. Okay. Again, area and perimeter, we're going to work on both. This time I'm going to start with area because I want to make sure that it's clear when I'm looking at the marks on here. So there's 2 ways to deal with a weird shape when you're dealing with area. You can either cut it up into normal shapes and find the area of each of those shapes and add them together, which makes sense when you have shapes that are like kind of look like maybe a couple of rectangles. It's probably really easy to find this area and then add them together. The other way is by taking it, if it's a weird shape that looks like it has cutouts, find the area of what it would be if it was a whole rectangle and then subtract off those pieces. And so for this shape, I'm going to pretend that this is a full rectangle. Okay, and so this is 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 5, 6. So the whole thing is 42, and now I need to subtract off those pieces. So I'm going to draw a division right here. This little piece right here is a rectangle, and it's 1 by 2. And so that just has an area of 2. So I'm going to take 2 away. This is a triangle. This would be the right angle. It's a right triangle. It's 2 by 1. The formula for the area of a triangle is 1/2 base times height. So 2 times 1 times 1/2 would be an area of 1. This one is 1, 2, 3 by 1, 2. So again, when I'm doing that, 2 times 3 is 6, divided by 2 is 3. So my areas to subtract off are 3 plus 2, which is 5, plus 1. So if I take 42 minus 6, my area then would have to be 36 units squared. Okay, now I could have broken this up into a bunch of different little pieces and added them all up, but there's going to be some weird shapes, and so it's probably the easiest in this case to treat it like a big one and then subtract off the pieces that I don't want, as opposed to taking it and doing the individual pieces. So let's look at perimeter. Go ahead and erase this. All right, so as I'm looking, take some of this away. As I'm looking at perimeter, again, I'm going to start with my vertical and my horizontal pieces. This is 2. This is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. This is a diagonal. That's no help. That's 2. And this is 1, 2, 3, 4. So I start with those. It makes it a little bit easier. In order to get those pieces. And now I've got to get this diagonal and this diagonal. Okay, well, looking at these diagonals, it's not a Pythagorean triple, and neither is this one. So I have to use the distance formula on both of those. They're not the same slope. They're not going to be the same length. So I do need to do that. So this point is going to be -3, 0, -2, 2. So I'm going to use those 2 points in my distance formula. So again, the distance formula is going to be x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And I'm going to substitute that stuff in. All right, so if I start with -3 minus -2 squared plus, that's going to be 0 minus 2 squared. Okay. This is going to give me 1 because minus a -2 is going to be +2. So that's going to be -1 squared plus that's going to be -2 squared. When you do that, you get 1 plus 4. So it's the square root of 5, which is approximately 2.24. So this is about 2.24 because it's not a perfect square. So when I take the square root, that's what I'm going to get. If I do the same thing with these points, F is going to give me 4, 1, and E is going to give me 2, 4. Just making sure. Okay. Yep. And so 2, 4. So looking at those points, again, I'm going to substitute them in. So 4 minus 2 squared plus 1 minus 4 squared. And so that gives me 2 squared plus -3 squared. So basically 4 plus 9. So I'm looking at the square root of 13, which is approximately 3.61. Okay. So now that I have all of my numbers and values that I need, okay, I can just add up all of those sides. So I've got, if I'm going to start here at A and just work my way around, I've got 2 plus 2.24 plus 2 plus 4 plus 3.61 plus 3 plus 7. And so I'm going to add all those up in order to find the perimeter. So that's 10, 14, 16, 18. If I add these two together, that's 5, 8, and 5. And so that would give me 2385 is my approximate perimeter. So the perimeter would be 2385 units. Okay. So when you have to do a diagonal, you have to use the distance formula. It takes a lot more steps. When you can do the horizontal and the vertical just by counting, that works a lot better in terms of easier to calculate. But hopefully this helps, and have a great day.